Alrighty, so we're studying lines and slope and graphs and stuff. So for these questions, we're talking notes part 2. We have a graph that's shown, and what we're supposed to do is get this information from it. So first of all, when we're talking about the slope, we could rise and run between 2 points. So we'd go down 3 and then right 2. So when we're talking about the slope, our rise was -3 and our run was +2. So you could talk about it as -3/2, or just write the negative in front of the fraction like that. And then for the intercepts, this is where x-intercept, this is where it crosses, this is the x-axis, and it crosses at 2. So we can say that the x-intercept is 2. For the y-intercept, this is the y-axis, and we're talking about where it crosses. So it crosses at 3, so we could say the y-intercept is 3. And when we talk about the equation of the line, we're using slope-intercept form. So it's always y equals mx plus b, where we're putting in the slope right here, and we're putting in the y-intercept right here. So notice how the x-intercept is not used in the equation. We do know what it is, but we don't need it to write the equation. So for the equation of the line, we can say y equals -3 halves x plus 3. Voila. Okay. So number 2, same thing. Slope, we do rise over run between 2 points. So we'd go up 1 and then right 3. So I was in up 1, right 3. So rise over run is a +1/3. Our x-intercept is back here at -3, and our y-intercept is up at 1. So the slope of our line, we could, using slope-intercept form, we could say y equals 1/3 x plus 1. Voila. Number 3, let's see, for our slope, we would go rise 2, run 1. So our slope is 2/1, which we could simplify to just write as 2. X-intercept, we're talking about where it crosses the x-axis. Okay, whoops, had a little pause there. Where were we? We got the slope of this. And then x-intercept is -1, and our y-intercept is 2. So where'd that come from? X-intercept, here's x-axis, so it's at -1 is where the line crosses. And on the y-axis, the line crosses at 2. So our equation, we're again using slope-intercept form. So we can say y equals our slope times x plus our y-intercept. It's just a coincidence that these two numbers are the same. You could also write, or you could say y equals 2/1 x plus 2. Same thing. Good work. Okay, number 4. So, similar. Our slope for rise and run, we're going 1, 2, 3, 4 down and 2 to the right. So -4/2, which could divide, this is an equal sign to give us -2 for our slope. Our x-intercept is -2. Our y-intercept is -4. Where'd those come from? X-axis, line crosses at -2. Y-axis, line crosses at -4. Okay. And for our equation, using slope-intercept form, we have y equals, and it would be -2x, that's our slope. Our slope is -2 times x minus y-intercept, so 4. Like that. Alright, so don't be too disappointed, but on the back side, it's not a now you try. These questions are slightly different, so I do want to show you this. Oh, where's my graph paper? Man. Okay. Well, here we go. So our x-intercept is -3 and y-intercept is 3. So we're going to draw a graph, and we know these points are on it. So an x-intercept of -3 is here, and a y-intercept of 3 is here. And just with those 2 points, not using slope, we're going to graph. So again, x-intercept of -3 was here, y-intercept of 3 was here, and I connect them. And so from my graph, this nice beautiful graph, I'm going to figure out the slope and the equation of the line. So let's see, rise, we go 1, 2, 3, and 1, 2, 3. So slope, rise over run, 3 over 3, which if we divide, that would give us a positive 1. And for the equation then, we could say y equals slope times x plus y-intercept. So we could write it like that. You could also say just y equals x plus 3, and that would be correct. Whew. All right. Tough stuff. So let's take a look here. X-intercept is 2, y-intercept is 4. Nice even numbers. Really like that. So here's our x-intercept of 2, and here's our y-intercept of 4, and here's what this looks like. It's not a very straight line. Hey, collaborate, what? Okay, and here's our nice straight line, rise over run between them, so that's our graph, and then we can go 1, 2, 3, 4 down, and 2 to the right, so our slope, we get -4 for the rise and 2 for the run, and if we divide those, -4 divided by 2 is -2. So for our equation, again, we're just saying y equals slope times x plus y-intercept. Oh yeah. Number 7, nice beautiful graph, like so. And so let's see, x-intercept of 1 and a y-intercept of 3, and I need to take that over. Nice, beautiful, straight line. So there's our graph. Let's find our slope. Rise, so we went down 3 and right 1. So over slope, down 3, right 1, and we could write that as just a -3 if we wanted to. For our equation, we would say y equals slope times x plus y-intercept. If you wanted to write that because you had this as your slope, that would be just fantastic. And number 8, x-intercept is 4. So let's see, x-intercept on the x-axis, there's 4, and our y-intercept is down here at -2. Connect them with a nice straight line, and it looks like a positive slope. I wonder what our slope is. Let's see. Rise 2, run 4. So for a slope, we rise 2 and run 4. So you could leave it like 2 over 4. If you wanted to reduce or divide to get 1/2, that would be cool. So we could say y equals, we have 2/4 x plus our y-intercept. So -2. So this is all good. If we wanted to say y equals 1/2 x, and then plus a -2 is like -2. So this works as well. Both of those would be okay. Thanks.